Okay, hello everyone, welcome back to our channel. So today we'll discuss one more question from the 2018 June CSIR physics question. So today the question is as we can see from quantum mechanics, and the question says that at t is equal to 0, the wave function of an otherwise free particle confined between two infinite walls at x is equal to 0 and x is equal to L is psi x t equal to 0 is equal to root 2 by L sin pi x by L minus sin 3 pi x by L, and it is asking that its wave function at latter time t is equal to ml square 4 by 4 pi h cut is. So we have to find out the wave function after latter time t is equal to ml square by 4 pi h cut. Okay, so see, so this question is related to the Schrodinger equation. So using the time, basically we have to use the relation between the time dependent Schrodinger equation and the time independent Schrodinger equation. I hope most of you people know, but before that I am just going to solve how to going to find out the relationship between the time dependent Schrodinger equation and how we can convert the time independent wave function to a time dependent wave function. So there is a formula from where we can find the time dependent, this is the time independent wave function as you can see, and to time dependent wave function. Okay, so as we know, the time dependent Schrodinger equation is that is I h cut dou psi r t by dou t minus h cut square by 2m del square psi r t plus the potential energy u r t, which depend on the time. Okay, so this is the Schrodinger equation. As you can see, this is the Schrodinger equation, and this is the time dependent Schrodinger equation as you can see. So when this potential energy, see, this is the potential energy, when this potential energy is independent of time, so that means this potential energy doesn't depend on time explicitly. We can write this psi rt, this wave function psi rt, as the product of a function psi r of the spatial part and a function ft, that is the time part. Okay, so this psi rt can be written as equal to, so this psi rt can be written as psi r, we can separate psi rt, this is wave function which depends on position as well as time, which is a function of position and time. We can separate these two to a function of a spatial function and a time function, provided the potential energy, provided this potential energy u is independent of time. When this potential energy is independent of time. So now as you can see, we if I substitute these two things to here, I will get, I hope everybody knows this derivation, but for BSc students it will be helpful, or for the beginners. Okay, so if I will substitute this here, this becomes I h cut dou by dou t. See, this is only a function of time, so this is a partial differentiation with respect to time, so this will only derive this part, time part, and here I have psi r. Okay, that equal to, just I am substituting psi r t equal to psi r and f of t in place of this function, this wave function. Okay, so this becomes minus h cut square by 2m del square. This becomes okay, plus, let me separate this like okay, this is psi r, I can take this out, and f of t, I am writing f of t here. Okay, so if I will take this one to right side and this to the left side, the equation becomes I h cut 1 by f of t d f of t by dt, because as it becomes the function of only time, we can change this differentiation. Okay, but from partial to the direct differentiation, taking the r part out right to the right hand side, this becomes minus h cut square by 2m del square plus u of r psi of r. Okay, so now as you can see, if I will divide psi of r and f of, okay, just a second. Yeah, if I will divide here, see, if I will divide psi of r and f of t on both sides, so I will get here 1 by psi r 1 by psi r f of t, so psi r will get cancelled, so I will remain with 1 by f of t only. And in the right side also, if I will divide 1 by psi r and f of t, here also f of t gets cancelled out, and I will just remain with 1 by psi r. Okay, so as you can see, the LH of this equation, the LHS of this equation is the equation depends only on time and is independent of r. As you can see, this function is only depends on t and is independent of r. Similarly, this right hand side is only depending on r and not depends on time. That means independent of time, and this is independent of r. And in the left hand side, this is only the function of time, and in the right hand side, this is also only a function of position. Okay, so we can this each side must be equal to a constant which is independent of both r and t. So we can equate individually this equation, this left hand side to a constant and the right hand side to a constant. Okay, and this is known as our separation constant. So this becomes I h cut 1 by f of t d f of t by dt equal to some constant e, and also we can write 1 by psi of r, this total part right hand side minus h cut square by 2m del square plus u r psi of r is equal to that constant e. Okay, so from this equation, as you can see, if I will just do the integration here, like df of t by f of t is equal to this will become minus I by h cut 1 by I h cut. So I am writing this as, this will become this, if this goes to the right hand side, this becomes 1 by I h cut, and 1 by I h cut, and I can write minus I by h cut. So this becomes e. So after the integration, this will be log of f of t, and in the right hand side this is dt. Okay, so this becomes only minus I by h cut et. So we will take the logarithm to the right hand side, this becomes exponential. So this f of t becomes e to the power minus I by h cut e. Okay, this is important. Okay, and also and this one also equals to e, this one also equal to e. So this will become this equation becomes 1 by minus h cut square by 2m del square plus let square psi plus u r, this is a function of r only, psi r is equal to E psi of r. So this is the time independent, this is time independent Schrodinger equation and time independent Schrodinger equation, and this equation, from this equation if I will substitute the value of f of t in this psi of r into f of t, let's see, I'll just substitute the value of f of t here. So I will get psi of rt is equal to psi of r e to the power minus I e by h cut. This is the important relation. So from this equation I can find out the wave function at a later time t. If I have at a later, okay, there is a t here, sorry, so here there is a t. Okay, so from this equation, that is psi rt is equal to psi r e to the power minus I e t by h cut. This t will come from here when I will do the integration. Here log of f of t minus I by h cut e integration of dt is t. So there will be a t here. Okay, so which I was left. Okay, psi rt is equal to psi r e to the power minus I e t by h cut. So this is the important relation, and from the, if I know the wave function at time t is equal to 0, I can find out the wave function some later time t if I know the value of t also. So this equation is applicable for this particular question. Okay, so if I know any wave function that may be in a 1D box, that may be in for the harmonic oscillator, or that may be for a potential well or anything, or potential barrier. So if I know the wave function at time t equal to 0 and I intend to find out the the wave function at later time t, so I can use this equation and find out the wave function. So now I will jump to the question. So this as according to the question, it says that there is a like at t is equal to 0, the wave function is given. This is the wave function, and we have the time t. So just using this equation I can find out the values. Okay, so this is for 1D box. So we know that for 1D box, we know that the wave function is equal to this psi r or psi x equal to under root, here we can write x here, psi x is equal to under root 2 by L sine, this is psi n x, I can write sine n pi x by L, right? So n is the, where n is equal to 1, 2, 3 and so on. This denotes the ground state, or for n is equal to 1 we will get the ground state, for n is equal to 2 first excited state and so on. And the energy eigenvalue is given by n square pi square h cut square by 2m L square. So this is 1D box which is from 0 to L, right? We know that. So this, if this is the 1D box that is having infinite wall, so this is infinite wall, so on this goes to infinity and this goes to infinity. So this from 0 to L, that means the particle, free particle, that particle is free, so the particle is trapped inside the box. That particle can't go beyond this wall and can't go beyond this wall also. So this is, the particle is trapped inside this box. Okay, so by doing the mathematics over here, we got these two values, psi n x is equal to under root 2 by L sin n pi x by L, En is equal, and the energy eigenvalue corresponding to this 1D box is n square pi square h cut square by 2m L square. Okay, so by this equation, from this equation also we can see these, sorry, okay, just a second. Oh, this equation psi 1 for the ground state becomes under root 2 by L sine pi x by L, and the according to the question, the psi 2x also becomes under root 2 by L sine by 3 pi x by L. This is the, sorry, this will be 2, and the second excited state psi 3 is equal to under root 2 by L sine 3 pi x by L. These are the, and the energy corresponding to this data, this is an E3 is equal to 9 pi square h cut square by 2m L square, and corresponding energy corresponding to this is equal to pi square h cut square by 2m L square, depending on the values of n. For n is equal to 1, we will get the ground state. This is for first excited state, and this is for second excited state, and so on. Okay, so now coming to the question, see, just I have to arrange this question according to the ground state and first excited state, and so on. So if I'll see this this question says at the psi x is equal to under root 2 by L sine pi x by L minus sine 3 pi x by L. This is the ground state, and this is the wave function of the free particle at time t equal to 0. So see, the process is you have to first express this wave function. This C, we can express easily this function into the wave function of a 1D box, right? But you will face some question which is not in this order. So we have in this format, sorry. So in this you will get some question which will not in this format. So for that case, you have to do it carefully. Like you have to convert this wave function in terms of in the format of 1D box. Okay, as we know, psi 1 is equal, so I can write, see, under root 2 by L sine pi x by L is nothing but psi 1 of x, and this is nothing but my psi 3x. Okay, ground state and the second excited state. Some in some cases, I am just giving some example. You will see that there is like not under root 2 by L, there is something like 1 by 10 or pi by 10, anything like this, or 10L. Example I am just giving. So you have to convert this part in the term of this one, so that you can express this wave function in terms of the ground state, first excited state, and second excited state accordingly. Okay, got it? So you have to you have to observe these things. Okay, so now we know we can convert psi x to psi xt as psi of x e to the power psi n xt is equal to, I can write psi n x e to the power minus I e n t by h cot. This is my formula to convert the time independent wave function to time dependent wave function. Okay, so if I'll see, okay, so this becomes psi 1 x, this psi xt will become psi 1 x e to the power minus I e 1 t by h cot, and this will become psi 3 x e to the power minus I e 3 t by h cot. See, now I can do this. You can do these things. So psi 1 x, we have t, we have e1 already. E1 is, okay, I am keeping this aside, and e1 is for pi square, this is 1D box, 2ml square into our time is given, and time is equal to ml square 4 by 4 pi h cot. So substituting this here, Actually, this will not take any time. Like if you will practice this, you got these things clear, then you can like directly see the question, and within 1 or 2 minutes you can figure out the answer. So this is minus psi 3 x e to the power minus I by h cut. E3 is 9 n square pi square h cut square. So this is 3. So this will become n square pi square h cut square by 2 ml square into ml square by 4 pi. This becomes clumsy a little bit, but I think you got the idea about these things. So I can cancel this one. This will get cancelled over here. This will get cancelled over here. So I'll get here psi 1 x e to the power minus I h cut. This will be pi, this h cut square get cancelled, here I'll get this is by 8. Okay, no, there will be no I, as ml square by 4 pi h cut square h cut square. I get here pi h cut in the above. Okay, minus I pi h cut by 8. I hope. Okay, just give me a second. Just I'll check this one. Pi square h cut square by 2 ml square into ml square by 4 pi h cut. So h cut square will get cancelled. Pi square pi 1 pi h cut, and here l square. So okay, correct. This one is correct. Okay, so minus I pi h cut by 8. Similarly, for this one, I can minus I by h cut. Okay, there is one more h cut over here, so this will also get cancelled out, only minus I pi by 8. Okay, so this will become like minus e to the power minus this will get cancelled out. So you can see, by cancelling out, I can get here minus 9 pi by 8. Okay, this is pi h cut. So psi 3x e to the power minus I pi by 8 minus psi 3 of x e to the power minus I 9 pi by 8, and this is psi 1. So you have to, for such questions, you have to just see the form in which format the answer is given. So now in this question, but this particular question, the format is in terms of under root 2 by L sin. This is also converted to in terms of this term. Okay, root 2 by L sin pi x by L minus sin 3 pi x by L e to the power minus here I pi by 8, and here this is minus I 9 pi by 8. This will be the answer for this question. Okay, just you have to see. This will I am not going for the exact answer, because you can find out this by converting this one if you know the answer, you know the question. Okay, so just this is the process, this is the method. My intention is to reach you what is the process of the process of solving the answer, solving the question. Okay, so I hope you guys got this, and we'll discuss something more in the new video. Okay, so I hope you guys are well and good, and if there is any doubt, you can comment in the comment section. So thank you guys.